This video demonstrates the Island Energy Scenario Tool developed for the Department of Energy's Office of Energy Efficiency and Renewable Energies Technology to Market program. The Scenario Tool is designed to help energy managers on various islands determine the best options for reaching their clean energy goals. The tool works by having the user set up an electricity demand and supply scenario for a grid or a set of grids using various energy technologies, such as conventional fossil fuels and renewable generation. The tool can support up to 5 locations or grids. This is an important feature for modeling island scenarios which might have one or more small grids. The tool provides a comparative analysis among different scenarios in terms of the cost and level of generation required by each technology to meet demand, and reveals which generation resources are the best investments for the long term. Users of the tool will need to input a lot of data initially, but once data for the first scenario is added, the tool allows scenarios to be copied. This makes creating additional scenarios less time-consuming. Before using the tool, it is important to understand all the data that is required to create a scenario. This video offers a step-by-step tutorial so that you can use the tool effectively. Let's get started. We will now open the tool beginning at the Scenario Details screen, which features the main menu and serves as the starting point for using the Island Energy Scenario Tool. On this screen, users can create a new scenario, copy and modify an existing scenario, review an existing scenario, and delete scenarios. Please note the left-hand navigation, which allows users to toggle between each tab in the tool. The first step on the Scenario Details screen is to either create a new scenario or copy an existing scenario using the text boxes, drop-down menus, and buttons here at the top of this form. When an existing scenario is copied or open for review, all of its existing data will populate on all data entry screens. On this screen, you can also delete scenarios. Please note that the Delete Scenario button removes the entire scenario, including all data entry on the subsequent tabs from the Scenario tool. This deletion is permanent. The second step is to determine the scenario duration. All scenarios are assumed to start in 2014 and can extend a maximum of 30 years or until 2044. Your next step is to select the number of locations to model in this scenario. Each scenario comprises 1 to 5 locations, and each location must represent a distinct electric grid. For each location, you must also enter spinning reserves, which are added to total demand, the clean energy target for the end of the scenario, and the renewable portfolio standard target for the end of the scenario. In the Scenario tool, clean energy is defined as the combination of renewable energy generation and reductions in demand due to energy efficiency. After entering the data in this section, click the Save Scenario Inputs button. Your next step is to select the energy resource types to use in this scenario. Both conventional and renewable sources are available. Custom energy resources can be used for new technologies or to model projects that have different capacity factors. After selecting the renewable and non-renewable energy resources to be used for the scenario, click the Save Scenario Energy Types button to save. Next, go to the Shared Resources tab. This allows an energy resource to be shared by multiple locations or grids. For example, to model an undersea cable project connecting the grids of 2 islands where a wind project on one grid is supplying a percentage of its power to another grid. Only custom energy resources can be modeled as shared resources. You can skip this tab if you have no shared resources. Always click the Save button before proceeding to the next tab. We will now review the Baseline Inputs tab, where you will input 3 types of baseline demand for each location: projected electricity demand, energy efficiency, and electrical vehicle demand forecast. Projected electricity demand data provides the foundation for demand calculations, and energy efficiency is modeled as a reduction in that demand. Electric vehicle forecast data is optional and can be left blank. Baseline data can also be copied from previously saved scenarios using the Copy Baseline Data from Existing Scenario menu. This list of scenarios includes scenarios with locations that match the selected location. Baseline data can also be created by inputting a starting value and then automatically increasing over the duration of the scenario using the Apply Percentage Increase Over Scenario checkbox and accompanying percentage data field below. We will now move to the Resource Potential tab. Resource potential is defined as the maximum generation level in megawatts that theoretically could be installed for each energy resource. In the Island Energy Scenario tool, resource potentials serve as a ceiling for each energy resource and must be set for each location and energy resource combination. The tool will not allow a scenario to add more generation supply than the resource potential established for each generation technology. Data can also be copied from previously saved scenarios that include the same location. The next tab requires the entry of capacity factors. Capacity factors represent the maximum electric output a plant can generate under specific conditions and are used to account for variations in generation profiles across technologies. In the Islands Energy Scenario tool, capacity factors are percentages applied to the nameplate capacity of generation projects. The tool allows you to set up different capacity factors for the same technology using the custom energy resource types set up on the Scenario Details tab. For example, if a wind project in one location has a higher capacity factor than another location, you can set up a custom energy type and apply the capacity factor in this table. The next step in entering scenario data is to enter renewable generation project information into the Renewable Generation Project Inputs tab. Projects are added to the scenario one by one using the Add Generation Project button, and more projects can be added or deleted at any point. You need to specify a name, energy resource used, the year the project came online, and the nameplate capacity. To model project renovations or expansions, you can also add a one-time increase in project installed capacity during the scenario using these fields. For residential and commercial solar, the Island Energy Scenario tool allows you to create an incremental increase in the levels of penetration over the scenario. Simply enter a starting capacity and an ending capacity, and the tool will distribute the increase evenly over the time period using the Automatically Increase to Meet Target radio button. In the Non-Renewable Generation over Scenario Duration table, you will enter the total combined amount of non-renewable generation at each location in the scenario. Unlike renewable generation, non-renewable generation is modeled as the total amount of generation rather than as projects. On the non-renewable generation capacity screen shown here, you can enter data in two tables that capture the total amount of non-renewable generation capacity and distribution of that capacity across fuel types. You can also use the Use Non-Renewable Generation to Meet Demand checkbox to automatically calculate the difference between annual electricity demand and supply met by renewable generation projects. The second table for non-renewable generation data enables you to enter the allocation of the fossil generation that is from each energy type. The percentage of the total allocation to that type must be entered, and the total must equal 100%. The Island Energy Scenario tool also allows you to change the distribution over the length of the scenario. The Use Constant Distribution Over Scenario Duration checkbox above this table can be checked to speed up data entry and use the same distribution for each year of the scenario. You will enter all financial data for the energy resources used in the scenario from the Financial Data tab, which brings up the financial input screen shown here. Similar to the other data entry screens, financial data is entered for each location in the scenario individually. However, once data for a single location has been entered, that data can be copied to other locations in the scenario using the Copy Financial Inputs to All Locations button. The next category of costs on the financial input screen is fuel data. The fuel costs entered here are used to calculate the total cost of fuel consumption for the scenario. All of the fuel types used in the scenario will populate automatically so that you can input the associated cost. There are several units of measure available in this drop-down menu, and a fuel escalation percentage can also be applied if you want to reflect rising fuel prices over the scenario duration. The third category of costs captured on the financial input screen is energy efficiency. Costs for energy efficiency are entered as a cost per megawatt hour of avoided demand. You can also apply the same cost to each year of the analysis using the Use Constant Cost of Energy Efficiency in Scenario box above the table. The fourth and final financial data type entered on this screen is investments in grid upgrades. You can model these costs as flat additional costs, and they can be incurred every year of the scenario or only for years you specify. The Scenario Dashboard tab displays the status of data entry for the scenario and shows all output metrics. The information on the screen is read-only and shows data that has been entered and saved previously. You'll want to pay attention to the Data Requirements table, which shows the status of data entry for the scenario. Red circles in the table indicate missing data, yellow circles indicate incomplete data, and green circles indicate that data entry is complete. The first table on the Scenario Dashboard shows the scenario start year and duration for reference. The second table shows the clean energy and renewable portfolio standard targets for each location and for the scenario overall, as well as the actual percentage for each. This dashboard also gives you the ability to run reports, which are spreadsheet downloads of all the data shown in this dashboard. Below the Scenario Energy Targets table is a drop-down menu that controls the view of the tables below it. This menu allows you to view the output metrics as scenario totals or as an individual view for each location. The electricity demand and supply table shows a number of summary metrics including the projected demand, energy efficiency, fossil fuel energy supply, renewable energy supply, and more. The distribution by energy resource table shows supply and cost outputs for each of the energy resource types in the scenario. Below these tables are two charts that display the energy distribution for the scenario and the amount of total supply over the duration of the scenario. Using the radio buttons above the pie chart, which shows the distribution of energy types for the final year of the scenario, you can select all energy types, renewable energy only, or non-renewable energy only. In the area chart, energy efficiency is displayed as having a negative impact on demand. The final table on the Scenario Dashboard shows supply and cost outputs separated by new projects and existing projects for the scenario. As with the other tables on the dashboard, the Financial Details table can be viewed for the entire scenario or for an individual location using the drop-down menu toward the top of the screen. The benefit of this tool is that it can provide comparative analysis when running multiple scenarios for one location. For example, you can compare costs between scenarios to understand how investments in different renewable technologies would have the most impact. The tool also allows for you to run scenarios and then compare them to understand how much of each energy technology is required to meet your goals. In this example, we see one scenario in which the investment in wind is significant. In the second scenario, the goal is met by increasing levels of geothermal, solar, and biofuels. This concludes our demonstration of the Island Energy Scenario tool. We hope that it has helped you understand the data you will need to create a scenario and use the tool successfully. In addition to watching this video, we recommend that you reference the tool's user guide, which is also available on this webpage.